The Bohr model of the atom. The Bohr model of the atom is an effective way to represent the first 20 elements. Each electron orbit is shown as a ring around the nucleus, with the first orbit having a maximum of 2 electrons, the second orbit having a maximum of 8 electrons, and the third orbit having a maximum of 8 electrons as well. Bohr-Rutherford diagrams. So how do we draw our Bohr-Rutherford diagrams? Well, first of all, we need to determine the number of electrons. The number of electrons is going to equal the number of protons, which is going to equal our atomic number. Next, we're going to determine the number of neutrons. Remember, number of neutrons is going to be the mass minus the number of protons. Then we're going to draw a circle and write the number of protons and neutrons inside. We're then going to write the element number underneath, and then we're going to place the electrons in their proper orbit. We're going to fill up the first orbit with 2, and then 8, and then 8 if we have enough electrons. We're going to add them individually in the north, so we're going to go north, south, east, west direction, and then we're going to pair up any extra electrons. So let's just say we had 6. So then we go back to north, and then we go to south. Now I drew dots here, but typically what I'll do is I'll actually draw X's. So I'll go north, south, east, west, and then north, south, east, west. So here's an example of what it looks like. So if we take a look at, in this case, it's sodium. So in sodium has 11 protons and 12 neutrons. So we figured out the number of electrons. The number of electrons equals the number of protons, so we got that. The number of neutrons was the mass minus the protons, so 23 minus 11 equals 12. We drew our inner circle, so we have 11 protons and 12 neutrons on the interior. We have our symbol, Na, and then number 5, you can see we have our full Bohr-Rutherford diagram. We put our 11 protons and 12 neutrons in the middle. We draw a circle around it, and then we draw our orbits. So we have our first orbit here with 2. We have our second orbit with 8, and then we have our third orbit with just 1. And that gives us 11 total electrons. 2 plus 8 is 10, plus 1 is 11. Now, the only time that we pair our electrons right away is in the first orbit, and we'll see an example of that on the next slide. So let's take a look at helium. Helium has 2 electrons. So we're going to put helium down here. So let's write out everything we need. So number of electrons is going to equal to 2. The mass of helium is 4. The atomic number is 2. And the number of neutrons is going to equal to 4 minus 2, which is 2. And that gives us all the information we need. So we're going to write 2 protons, 2 neutrons in the center. And we're going to put another orbit around. So same thing. And we're going to put our 2 electrons in that first orbit. Now the first orbit, again, is the only one where we pair up the electrons right away. So we're not going to go north-south. We're going to put 2 in the north. And we're done. That's the Bohr-Rutherford diagram for helium. Neon. So the first thing we're going to do is we're going to write neon below. And then we're going to make our chart. We're going to say atomic number. We're going to have mass. We're going to have number of protons, number of neutrons, and number of electrons. So the atomic number of neon, we're told, is 10. It has 10 electrons, therefore it has an atomic number of 10. The mass of neon when we look at the periodic table is 20. Number of protons equals the number of electrons, so that's 10. Number of neutrons is going to be 20 minus 10, which is 10. And the number of electrons, like we said, is 10. So now we're ready to draw a Bohr-Rutherford diagram. So inside our first orbit, we're going to write our number of protons and neutrons. We're going to write 10p and 10n. And then we're going to draw a circle, and that's going to be the nucleus. Then we're going to draw another circle, and that's our first orbit. In our first orbit, we have 2 electrons. So we're going to keep a tab over here. So we have 10 minus 2, we have 8 left. After we do 1, 2, remember you pair up the first 2. Then we're going to draw our second orbit, and we have 8 left. So we're going to go north, south, east, west. That's 4, 5, 6, 7, 8. We've used all 8, so we have 0 left. And that is our Bohr-Rutherford diagram for neon. So we're done. Potassium. So we're going to write potassium down here at the bottom. We're going to make our chart. We're going to say atomic number, mass, number of protons, number of neutrons, number of electrons. And we're just going to really quickly draw a chart here. Now the number of electrons, like we were told, is 19. If there's 19 electrons, then there's going to be 19 protons, and we're going to have an atomic number of 19. The mass of potassium, when we look at the periodic table, is equal to 39. So the number of neutrons can be 39 minus 19, which is 20. So we know in the middle, we're going to have 19p, 20n. And we're going to draw our first circle. We're then going to draw our second circle. And we're going to put our 2 electrons in our first orbit in that first circle. And then we're going to draw our third circle. Okay, so we started with 19 electrons. We used 2. So now we have 17 electrons left. So now we can put a maximum of 8 in this second orbit here. So we're going to go north, south, east, west, north, south, east, west. 17 minus 8 is equal to 9. So we have 9 electrons left. So now we're going to draw our next orbit. We have 9 left. We're going to put 8 in this one. We're going to go north, south, east, west, north, south, east, west. Now, even if you know you have enough electrons, it's a better idea to draw them all out in the proper order. That way you don't make a silly mistake. So 9 minus 8 is equal to 1. So we have 1 electron left. So we're going to draw one more orbit. And we're going to put that electron right at the top, north. 1 minus 1, 0, and our Bohr-Rutherford diagram for potassium is complete. What does it mean to be reactive? We'll be describing elements according to their reactivity. Elements that are more reactive bond easily with other elements to make compounds. So what makes an element reactive? Well, an incomplete valence electron level, that's outer orbit. So for instance, in our example previous with potassium, we have an incomplete orbit. So we want to have 8 electrons in our outer orbit. And in potassium, you can see we only have 1. So it only has 1 valence electron. So since this outer orbit is incomplete, this particular element is going to be reactive because it doesn't have 8 electrons in its outer orbit, or in the case of hydrogen and helium, 2. So atoms will bond until this level is complete. Atoms with few valence electrons lose them during bonding, and atoms with 6, 7, or 8 are going to gain. So for instance, again, with our potassium, we only have 1 valence electron, so it's going to be pretty easy for us to lose that one instead of gaining 7. In our previous example, neon, it has 8 valence electrons, right? 1, 2, 3, 4, 5, 6, 7, 8. Since it already has 8, it is not going to be reactive. So it's not reactive because it already has a full valence orbit. In our previous example, helium, again, it has 2 valence electrons, 1, 2, and there can only be 2 valence electrons in the outer orbit. So again, helium is not going to be reactive. In the first example we did with sodium, sodium is exactly the same as potassium. And if you remember back to the periodic table, everything in group 1 has 1 valence electron. Well, sodium is just above potassium on the periodic table. So it only has 1 valence electron, and it will be reactive. So what makes an atom reactive? An incomplete outer orbit. It wants 8. If it doesn't have 8, it's going to react until it gets 8. Once it has 8, it's no longer going to be reactive. And that concludes our lesson on periodic table and Bohr-Rutherford diagrams.